時啊，明啦。咁 title set 定咗下場喎 ，title B 喎。咁你 set 咁轉咗呢個 A B 咁樣換咯。撳入去嗰個 folder 晒。
Good afternoon. Coming up next, we have Toby Cho to share Zoraxy, a reverse proxy server for networking beginners. Let's give him a big hand.
Right. Thank you for the introductions. I'm Toby Cho. Today I'm going to talk about Zoraxy. So this project is contributed by quite a number of contributors, and I'm the primary author here. I'm currently still a master student and a director of a startup company. So 2 years ago, I'm like a complete networking noob, right? I have zero knowledge about self-hosting or reverse proxy. Like I don't even know what is a domain. What is how can I host only a website with public IP address without the port card in the URL? And I don't even know how to set up HTTPS, like green lock in your browser. So anyone have the same issue like me before, like 2 years ago? No idea what the reverse proxy? Anyone? All right, one. Okay, seems to be all expert here, right? So I'm going to talk about basics of reverse proxy and why they're commonly used in homelab setups. So what is a homelab? A homelab is basically a server you put at home for testing lots of IT stuff. And it can be as simple as an old PC sitting in your closet, or a full-size rack, a professional rack, in your house basement. But most homelabs I know have something in between, something like a small rack with a few NAS and networking equipment at home. So a home lab are small-scale, non-production network environment for testing IT skills and learning a lot of new technologies. But recently, I'm seeing more and more people hosting their own servers, maybe an OPC or an old Raspberry Pi, for hosting services to replace subscription services, like maybe Nextcloud or RSOS, Google Drive, or Jellybean for replacing Netflix, etc. So in such scenario, a reverse proxy server is really important because it helps proxy the request from your downstream devices like your laptop with browsers to upstream servers like origin servers, like web servers, for example. And if you don't have a reverse proxy, like you own a domain name, right? And you want to create a new subdomain, you need a dedicated IP address for it, which is not quite feasible considering that we're running out of IPv4 address right now. So this is where the reverse proxy is important in such setup, because you can point multiple domains or subdomains into a public IP address that have your reverse proxy server running, and let the reverse proxy to forward the request to maybe a dedicated IP address or your local server in the local area network. And this is really important as the gateway of your homelab server because most of the open source projects rarely works together with shared web servers. Some rare exceptions like CGI or fast CGI with PHP server, but there's really exceptions right there. And a reverse proxy server is generally needed for your homelab setup if you're trying to run a lot of services into it. Like you can have your your domain.com pointing to your Jellybean instance, or your your domain.com pointing to your Portainer instance on different port. Like you're using Docker or virtual machines with IP address, etc. So, for such an important piece of software, there are obviously some already open source solution out there. One of them is Apache Nginx, which is the most traditional one that maybe an IT person would pick. But if you want to like something like a WebSocket proxy or geo IP access control, you need plugins and you need to write a lot of text-based configuration files, so not technically beginner friendly to start with. And for a more modern solution, there's a KD servers with a Golang, which is lightweight but still based on text-based configurations. The traffic proxy is a good alternative. It is commercial. It has a commercial and open source version, but their dashboard is quite limiting and can only perform some simple configurations. So if you ask the question on Reddit, like what is the best reverse proxy server you recommend, most Redditors will tell you to use the nginx proxy managers because it was the only one out there with a decent UI. But the downside of NPM or the nginx proxy managers is that it requires Docker to install, and if you're running on Windows, then you will see a lot of networking and NIC kind of issues right there. And from 2021, this project is rarely maintained, so most of the issues recently are complaining the application is broken. They have a V3 coming soon. They claim that it's written in Golang, but it also didn't update much since 2021, so I doubt it will come up anytime soon. So that's why I developed my own reverse proxy from scratch. And here comes the Zoraxy project. So what is Zoraxy? Zoraxy is an open source reverse proxy server solution with some handy networking tools. It's licensed in AGPL, run on Linux and Windows. Everything is a single binary file, so you don't need an installer or any kind of things. You don't even need Docker to run it. You just run natively on your Windows or Linux server. It has a beginner-friendly design with straightforward, buttons and UI stuff, with lots of automatic configuration generation built into the Zoraxy project. Many people coming from the nginx proxy manager complain of this project being too simple, or they're blown away by how the things are automated in the design of Zoraxy project. To sum up, the core about the Zoraxy is the reverse proxy based on HTTP 2 because more than HTTP 3 now. It supports virtual directory, WebSocket proxy, basic auth, alias, first name, custom handler. Basically anything you will find in the other reverse proxy project, you can find in Zoraxy. With the help of our contributors, we also added a lot of TLS SNI support, including ACME, SNI and send certificates, DNS challenge for less encrypted, etc. Other features include access control manager, so you can blacklist, whitelist, or rarely limit the country or IP address. If you're using ZeroTier, it also got built-in web UI for that, so you can have unlimited members in your game network. It also supports stream proxy, so if you are trying to proxy for your game server like Minecraft, then you can do it here as well. It also got a lot of utilities like integrated uptime monitors, web application terminal, and a lot of things. One of the key features of Zoraxy is that it has a wonderful or beautiful UX and UI element, including some of the most modern UI you can find in open source projects. Some of the interface also resemble other kind of open source projects as well. For example, you can find the default site settings and the HTTP proxy list kind of resemble nginx proxy manager of some kind. And also, if you are an AWS lover, you might be using Lightstyle before. You can use Zoraxy as a kind of a proxy for your SSH terminal, so you can access your cluster or your server in an enclosed environment with this web SSH tool, and uptime monitor, just like Uptime Kuma, where you can know if your server is down and if they are working normally. There are also some statistical analysis, which I will talk about it in later sections, but in general, you can see real-time data of your site in table and chart like this. So I guess most of you have never heard of Zoraxy before, because this is a really young project. It was a subservice module in the RSOS project. RSOS is another project of mine, which is a full-fledged web desktop OS. I added in just for fun. And later on, in 2023, I'm restructuring my distributed homelab, so I split this project off as a dedicated independent project for Zoraxy. And after so many enhancement requests and updates, now we got the Zoraxy V3, which is much more modern and efficient in reverse proxying. The problem is that you don't see a new reverse proxy pop up on GitHub every day. It's because it is really hard to test if a reverse proxy is compatible with other open source projects. Like maybe WordPress, for example, they require central headers, voice rewrite rule, and maybe sometimes other projects require web software update that is a little bit complex to configure. So instead of testing all open source projects and make sure it works with our proxy, we decided to test it on production instead. And where can we find free test users? Well, post it on Reddit. That's why we post our post on Reddit to share that we made a cool new project called Zoraxy, and the project started kind of skyrocket after we posted on Reddit. And this is a screenshot from our GitHub page. It has 17K public pool yesterday, and from what we see on Reddit, people are using it as an nginx proxy management replacement, which we didn't design it to be that way, but as more and more people from nginx community coming into this project, they are asking a lot of feature requests that make Zoraxy more and more looks like nginx proxy manager. And from the latest UI, you kind of see the Zoraxy UI resemble the nginx proxy manager in some way. And just to be clarified here, I don't intentionally copy the design or anything, right? You just, enhancement requests come in and then we just do it. After the third one of this project release, we got a lot of people dockerizing this app, which is a good thing. But the problem is that they are Dockerizing in a lot of different ways, I would say. And when people having issue with this Dockerized image, they come to our main repo and complain we don't make the app works. That is why in the third round of open source project, I invited one of the Docker maintainer into our project. And now we have an official Docker image. So Zoraxy in general speaking, in recent months especially, is getting more and more production ready. As this is a technical conference, I will talk about a little bit on how Zoraxy is built differently from other reverse proxy solutions. So first of all, many people confuse Zoraxy is like a UI for nginx or KDE, but instead, this is a project completely built from scratch using Golang. The good thing about working in Golang is that it's about Windows and Linux natively with the CPU architecture, so if you have an old router, old PC lying around, you just flash it into it. And it is self-contained, so it doesn't require JIT or runtime. And by the magic of Go embed, we can even embed all the web resources into the binary itself. So if you have Windows, double-click an exe file and your reverse proxy is deployed. It's that kind of simple. The disadvantages of this design is large binary size and no drop-in plugin. So if you want to add a plugin, you need to recompile the program, which we try to figure it out later. But if anyone got an idea for that, please let me know. This is the overall general structure of Zoraxy. I try to simplify a lot of things here, but you can see the downstream here, which is the user device, and your upstream is the server right here. And first of all, the request will go through the TLS router, where a lot of things is done here to, for example, like get you the correct certificate to serve your request. And it passes through something called the dynamic proxy router. Why it's called dynamic, I will explain it later. Afterward, we'll go to this special router handlers, which will check for like rate limits if you are coming from a country that has banned you, or you are an authorized user. And then if everything checks out, we'll go into the primary proxy router, where we call the DP core, dynamic proxy core, where the actual proxy logic is handled, including how to switch between HTTP upgrade to WebSocket, and then the request is forwarded to the backend servers. So let's come back to here. Why is it called dynamic proxy routers? The reason it's called dynamic proxy router is because we are one of the few projects that allow hot reload and partial reload of some routers modules. That means that if you change any configuration in Zoraxy, you can do a hot reload with no downtime. There are also more high availability features coming soon, including load balancing, automatic failover switching, multi-node context-sync, heartbeat, etc. But the magic of how we do the hot reloading is the utilizing of pointers of the manager inside the router options right here. I try to simplify as much thinking here as well, but in simple words, what we actually do is that because reverse proxy is a really high current and low latency software, right? There are a lot of requests coming in every second, and in order to make it hot reloadable, we actually use pointer swap techniques to swap the configuration and separate the abstractions of the reverse proxy logic into two layers. So dynamic proxy gives you a configuration on how this request should be routed, and the DP core is where the actual proxy logic handles. And by swapping the configuration pointers, what we can achieve is that even there's concurrent requests coming in, they will be able to have a real-time hot reload configuration, allow changes in the reverse proxy in real time with no disconnection or unstable connections. And after the connection using the old configuration is closed, the GC will kick in and clean up the old configuration. So everything is seamless and with no downtime. Also, Zoraxy is famous for its UI-driven design. If you work in the tech industry, you know more infrastructure delivers code. So for example, like nginx, you have a configuration files. And in Zoraxy, we try to develop it UX first in mind, and its web UI even support Out.D, so you can control your reverse proxy on your phone for no reasons. And this design, we are trying to minimize the operation cost for small business and homelab bursts, so that they can easily set up their reverse proxy without wasting a day in to figure out why the configuration is not correct. And just now, I mentioned about statistical analysis, right? The statistical analysis in Zoraxy requires no cookies. What it does is that it analyzes data purely based on header sniffing and Cloudflare hints. So if you use Cloudflare will send some headers with their request with some hints. And we use those hints to visualize them and show you your visitor data in real time using charts and tables. And you can even see where your visitors are coming from and what they are interested in. Talk about where they're from. Usually, if you think about geo IP resolving, you will call to some kind of AWS API or something like that. But the geo IP resolver in Zoraxy is completely offline and standalone, which means we don't use any kind of API dependencies. So it's perfectly safe for commercial use or with offline off-grid scenarios. It works by magic of custom written tree tree, so it has like 800 and 900 megabytes of tree tree within the program itself. So it can do a time complexity of near 0.1 speed of resolving the IP address into the country code. But of course, I know that some people are trying to deploy this on a router, like 10 years old router. So in order to compatible with those devices, we also implemented a fallback mode where it takes much more time complexity to resolve the IP address, but using much less RAM. There are also other worth mentioning features of Zoraxy might interest you to try using it, including one of the most easiest custom header editor out there. You can even just toggle some security headers like HSTS or permission policy and track the header security header checking method to give you an A grade. This is one of the key features of security experts will love this one. And as it is all integrated into a single binary, including the ACME and DNS challenge manager, so that with no ACME.sh or surfboard, this program works natively on Windows and Linux. So the Zoraxy also got automatic SNI and SAN certificate, so you can generate a wildcard, a domain certificate with wildcard inside, and allow them to automatically match your request coming in. In nginx Proxy Manager, what you will do is that you create a certificate and map it to a host name, right? In Zoraxy, that's automated. So many NPM users just don't get used to this design. Also, one of the features worth mentioning is called web SSH. This program is powered by GoPPY, which is another cool Go open source project out there. You can check out the link right here. And we use selective compilation to include this binary within our binary. So you can use your website, your browsers, to SSH into another server that is within the management scope of Zoraxy. From what I experience right now, most of the users using Zoraxy are for Docker use case. For example, you have a lot of containers hosting on a Docker network with different ports, and Zoraxy can proxy those requests from outside of the Dockerized environment and use subdomain to point to a dedicated instance. For example, like if you have Nextcloud running, you can point nextcloud.yourdomain.com to that Nextcloud instance running in your Docker with a dedicated port. Although Zoraxy works outside of Docker, it also works inside of Docker. But for beginners, we don't recommend this because most people will get a little bit troublesome in setting up the network configuration and how to forward the headers and those things, and making a lot of issues regarding the access control policies. So, as I mentioned earlier, I restructured my homelab structures, and this is how my current homelab setup looks like. I have a few instances, a few in Hong Kong, a few on Cloud VPS, and a few in my Taiwan home. And this is how I link everything together on my domain. Currently, Zoraxy is not production ready, but if you really want to try it, you can try it. And I've already got a few small businesses and independent design studio trying out Zoraxy, and all they are giving me some good positive feedback and improvement ideas. I know most of you are professionals here, but if you've got the time, feel free to contribute to this project because we are trying. Currently, we have a lot of users, and the user count is still increasing. And a lot of them are also beginners like me 2 years ago, where I had a lot of issues in setting up networks or how network routing actually works, and also a lot of bug report that is not actually bugs, but just they have misconfigured or something. So if you have the time and you know about how reverse proxy works, feel free to contribute by replying to these issues. This is all I'm going to share about today. And if you are interested to try out Zoraxy on your home lab, or maybe you have a spare Raspberry Pi, you want to host a website on it, feel free to scan this QR code and go to the project homepage. And if you have any questions, you can feel free to ask me right now. Anyone have any questions? Want to know more about this project? Yeah?
Do you plan to add support for encrypted client hello as well?
You mean TLS?
The extension for ECH
ECH.
is to hide the SNI.
No, currently there's no plan. And in fact, we have a dedicated maintainers who is from the US to handle anything regarding the TLS and the ACME part. So maybe you can open an answer request and ask him instead. Yeah, I mostly handle the reverse proxy core part. Yeah. All right. Oh, anyway, if there's no questions, then you can feel free to check out my repository and project homepage over here. And my another open source project is called RSOS, where you can remove the Zoraxy part of the domain and you can check out my another open source project. So I hand back the time to the MC.
Let's give him a big hand again. Thank you, Toby Cho, for a wonderful sharing. If you would like to discuss with our speaker about this topic, you proceed to the social area outside. The next session will be Michaelis Papas at 3:45 p.m. and he will be talking about beyond software defenses, hardware assist CFI on ARM-based systems.